What can travel through solids without making holes? What can travel and bounce and cannot be seen? What is that you make but cannot see? Well, the answer is very obvious. It's nothing but sound. Sound is generated due to a variety of events, like playing a musical instrument like guitar or tabla, swinging off the clapper of bell, bursting of crackers, and clapping of hands, etc. But how sound is produced? Sound is generated due to the rhythmic vibration of an object. For example, the bell, string, or diaphragm of a musical instrument. Vibrations are imparted to the molecules in the air. These vibrations reach our ears through the air and sound is heard. Vibrations of an object is necessary for generation of sound. These vibrations in air are called traveling longitudinal waves, which we can hear. Now let's understand the medium of propagation of sound. All vibrating objects are surrounded by some medium. It may be a solid, liquid, or gas. The traveling vibrations are called sound waves. Sound requires a medium to propagate. On the moon, there is absence of atmosphere and sound cannot travel through vacuum. Hence, one is not able to hear a call on the moon. The vibrations that produce sound can be studied with the help of a simple oscillator. Simple oscillator. The object moving from one end to the other end of its central position again and again in fixed intervals of time is called a simple oscillator or simple pendulum. A swing that moves back and forth like this is an oscillator. When the swing or the pendulum moves from one end to the other end and returns to its starting point, it is said to have completed one oscillation. The back and forth motion of an oscillator on either side of a central position is called oscillatory motion. Now let's understand certain characteristics of sound waves. The first one is amplitude. Let's understand this with the help of an activity. Take an empty porcelain bowl, stretch a rubber band as shown in the figure. Now, give a jerk to the rubber band. Repeat this action applying a smaller or greater force. While doing this, observe the farthest distance to which the rubber band is stretched. Take a note of the sound generated. When the rubber band is stretched from the original position A and comes to position B, it is seen to be curved. The maximum distance between the original position A and the position B on stretching the rubber is called the amplitude of vibration. Similarly, given an oscillatory motion to the pendulum, the maximum distance between the original position A of the pendulum and the extreme position B or C is called the amplitude of oscillation. In the given figure, AB or AC is the amplitude of oscillation. So now let's define the term amplitude. The maximum distance covered by an object on either side of its central position while undergoing vibration is called amplitude of vibration. Or in other words, we can term it as the distance between the mean or the central position to the extreme position of an oscillator on either side is called amplitude. The next term is time period of oscillation. The time taken by an oscillator to complete one oscillation is called the time period of oscillation. It is denoted by letter T. It is measured in seconds. The time required by an oscillator to traverse the distance B to A to C, and then from C to A and back to the original position B is the time period of oscillation. Frequency of oscillation. The number of oscillations completed by an oscillator in 1 second is called the frequency of oscillation. The total motion in the previous activity is one oscillation and hence can be represented as follows. Frequency is equal to 1 upon the time period of oscillation, which is equal to 1 upon capital T. The unit of frequency is hertz. 1 hertz means there is 1 oscillation in 1 second. 100 hertz means 100 oscillations in 1 second. The interrelation between length of the pendulum, its period of oscillation and frequency can be better understood with the help of the following activity, where the amplitude is kept the same, that is 5 centimeters, for different length of pendulums, that is 30 centimeter, 20 centimeter and 10 centimeter. The time period of oscillation depends on the length of the pendulum. As the length of the pendulum increases, the time period of oscillation also increases. Similarly, as the length of the pendulum decreases, the time period of oscillation decreases. The frequency of oscillation also depends on the length of pendulum. As the length of pendulum increases, the frequency of oscillation, that is the number of oscillations per second, decreases. As the length of the pendulum decreases, the frequency of oscillation increases. The time period of oscillation does not depend on its amplitude. Also, the frequency of oscillation of pendulum does not depend on its amplitude. As we know, vibrations are key to sound generation. Less vibrations result to low frequency or pitch. Pitch is how we feel or hear sound. It is closely related to frequency. Higher the frequency, higher the pitch. Lower the frequency, lower the pitch. The frequency of sound produced depends on the length of the string and the tension of the string. Frequencies of sound is inversely proportional to the length of the string. So, if length of the string is reduced, sound produced will be of high pitch. A sharp, high-pitched sound is heard. The tension in the string. On tightening the string, tension on the string increases. This also produces sharp, high-pitched sound. Thus, when the musicians tighten or loosen the strings, they are altering the pitch to make them sound in tune. The next is intensity of sound and sound level. Loudness or softness of sound is indicated by two terms, namely intensity of sound and sound level. Sound level is the intensity of sound as perceived by our ears. The intensity of sound is proportional to the square of the amplitude of vibration. For example, if the amplitude is doubled, the intensity of sound becomes 4 times as much. Similarly, if the amplitude is tripled, the intensity of sound becomes 9 times as much, and so on. The decibel is the unit for measuring sound level. It was named decibel in honor of the work of the scientist Alexander Graham Bell. The magnitude of sound level, decibels, can be deduced from the intensity of sound using a mathematical formula. When intensity of sound becomes 10 times the original, the sound level increases by 10 decibel. Decibel levels of some common sounds are mentioned in the chart. Hearing is temporarily affected by the sounds of frequency greater than 1000 Hz, or in other words, the sound levels higher than 100 decibel. This can result in temporary deafness. Workers who work near airplane engine experience this as the sound level is approximately 130 decibel. Based on the frequency of sound, it can be classified as infrasonic sound, audible sound, and ultrasonic sound. The human beings can hear the sound having frequency between 20 Hz to 20,000 Hz, and hence it is called audible sound. A sound having frequency less than 20 Hz is not audible to human beings. Therefore, it is called infrasonic sound. Sounds having a frequency less than 20 Hz are produced and can be heard by whales, elephants, rhinoceros, hippopotamus, etc. Ultrasonic sound. A sound having frequency higher than 20,000 Hz is called ultrasonic sound. It cannot be heard by human beings. Some animals like dog, cat, dolphin, sea lion and bat can hear such sounds. Uses of ultrasonic sound. Humans have used ultrasonic sound in different equipments and technologies to clean tiny parts of watch and delicate ornaments, to observe internal organs of the body, to detect tumors in the brain, to detect faults in a metal. Ultrasonic sound is used in radar systems. It is also used to kill certain microbes and insects. It is used in sonar technique, that is sound navigation and ranging, which is used to locate or determine the depth of seabed or the position of a ship. Thank you.